Then we will start with today's material. Hold on. Oh, I need to admit. I need to get to where we start. Okay. Hold on. I need to get where I can see the student. Where I can see the student, because there's student. Hold on. Okay, let me stop sharing to see. Okay, I would need to re-share. Because whenever there's student coming in, it's kind of disrupted. Okay, and we haven't get a chance to finish the first note in Numpy. Okay, it's a continued discussion about the quick start in the official Numpy tutorial, but with some of the new material I added. Okay, so what? Hold on, I need to admit. How do okay? And I needed to. Okay, so today what we will start to learn is about this function. And this, oh, hold on, okay, keep having student coming. And this function is quite useful with NumPy array, okay? So argmax. So let's take a look. So anyway, so here, if you recall, we already learned line space is a generate a sequence of number, is it with the step, with the specified step size. So anyway, you're going to get a NumPy array, is it? And then you reshape it. We reshape it as 5 by 4 to the array, okay, to the array. And over here, it's a do, hold on. View, and I need to admit both of them. For this data, so this is a NumPy array, okay, NumPy array, and you assign some generated numbers as it, and using sign and reshape it. Okay, so that's what this does. And this is what that array looks like to the array. So you have 2 level of square brackets, okay? And we have, it's a 5 by 4. There's a 5 row, 4 column. Okay. Hold on, I have 2 students coming. I need to admit both of them. And along the time, you may want to find the largest number along certain row or certain column, is it? And where it is, you want to know the row number or column number, okay? So anyway, generally speaking, with multi-dimension NumPy array, you want to know the largest item along a specified dimension, the dimension 0, dimension 1, dimension 2, something like that. Is that so? How do we do that? Then this function is very convenient to do that. So you specify the axis. Is it? So here it says axis is 0. The axis is 0. So what that means, if you take a look at the result, it says, okay, so this is what the result is. So then you get the corresponding index, okay, of that largest item in the specific dimension. Is it? And here if you take a look, it's 4. Also regarding column, is it? And why is this? Because what? Because axis 0 supposed to be row, is it? But here you are going to, because each of this number, is it? It's from a row, is it? You want to compare all of the numbers from all different rows, but along the specific column, is it? So that's why. So of course, this is the largest, is it? So that's why it gave 2, is it? And if you find the second column, this is the largest. So that's why it is 0, is it? So that's how this works, okay? And what it returns? It returns also an array, is it? And then it's an integer array, is it? Integer array. So what this means? So I'm not sure who still remembers why you can plug in that int d to this time array. Time is an array, is it? Because there's line space generated array. And why you can plug in this int? What does that mean? So if you recall, I'm not sure if you still recall, with our indexing and slicing, is it? You can use integer array. So this is an integer array. That's what it returns. Is it? You can use an integer array to do indexing. Is it? So over here, it's going to use those values to pick the corresponding item, pick out the corresponding item from the time array. That's how it get to the result. Okay. Okay, and then over here for the respective shape, that so you can see over here it's the column, okay. And then how do you pick up the corresponding largest item, that from that array, that? And the one way to do it is, because we already know the respective row number, that from the argmax, that. And then over here, so this is an integer array. Is it integer array? And then comma, if you recall, and then the second dimension, you have another integer array. Is it? So this is regarding first dimension. This is second dimension. Is it? We have a new student coming. Hold on. Oh, why it's just 9? Okay. Okay, so anyway, so then in this case, what you are going to do, it's with our indexing. So you do, hold on, okay. I cannot admit. Okay, so what it does is to do, hold on, I have another one coming. So what's over here? So if you have a numpy array and then you have first dimension comma second with another 2 integer array, what it does is to do indexing. Is it? Because it does the indexing. So this is for the column, second dimension, is it? And this is regarding first dimension. Is it? So that's why then you can pick out the respective items from that array. Okay. Okay, and you can also do something like this. Is it like data.max? You can also call the max function and then pick out the maximum number, is it, along certain dimension, is it? And if you do this, is it, if both are the same, is it, and you will find both are the same. Okay, so that's, then next, let's see over here. So here A anyway, it's some array, is it 0, 1, 2, 3, 4, that's what that array is. And what does this mean if you take a look here? It's kind of weird. Is it within it has 0, 0, 1, is it? And then over here you assign with what? With another sequence of number, is it? So what over here, if you take a look at the result, so this is indexing. indexing, is it? But with sub-zero, it indexed twice, is it? And it's updated first to 1 and then to 2, is it? So it says the sub-zero will take the latest updates. So that's why it will be updated to 2, okay? So 1 is gone, okay? And then the third item is updated to 3, is it? So that's that case. And if you take a look at this case, and it's just at +1, okay? And if you take a look at the result, it didn't, because 0, suppose you may think it's already at 1, should it be 2? No, is it? Because this at 1 is on the original array, okay? So whenever you do those operations, just be very, very careful, okay? What the next one try to show is about, it says you can also do indexing with Boolean array, okay? So NumPy also support Boolean array. So anyway, so here we have this sequence of numbers. So this is a NumPy array, is it? And what you do is says, okay, a greater than 4, is it? So this is try to do some comparison, is it? And you are going to get true or false. And why you can do this is broadcast rule, is it? Element wise. Is for NumPy, is it? We have that feature. So NumPy array has this kind of advantage. You don't need to write a loop to do that, is it? You can just write with the array and it automatically apply this greater than comparison to each individual element, okay? So over here, you find out if it's greater than 4, and you can clearly see the result is what? Is a Boolean array, is it? You get a Boolean array. And because of this Boolean array, you can also plug in Boolean array as indexing, okay? So that's why here it says indexing with Boolean array, is it? What over here, it's kind of just you write the for loop, is it? If it's true, then you pick out the item, is it? Yeah, but you see, if you use a Boolean array, then did you see it's how concise the code is, and also it's faster. If you run this, compare with you do the loop version, okay? And a lot of time this is quite useful, is it? Because you can use a Boolean array, then you can do some calculation, is it? In this case, it says, oh, with all of the true, you set it to 0, is it? So you can see how concise it is. You just use this element-wise comparison, then you just do the assignment to update, is it? Versus the true level of loop with 2D array 1 by 1, is it? It's much faster. And for this, because it involves with plotting later on, after we learn plotting, we can come back to revisit it. And what next one try to show is the second way of indexing with Booleans, okay? They're similar to integer indexing, okay? So let's see, how do we do this? So anyway, we have a 3 by 4 array, is it? So that's a 3 by 4 array. Then over here, we have 2 Boolean, is it? 2 Boolean array, true, false, is it? And then did you see over here, what it says is you can kind of also use Boolean array to do indexing and slicing, is it? So here it says, okay, for the first, what does this mean? Does it mean first dimension, I'm going to use this Boolean array to pick out the rows, is it? So I'm going to pick basically it's what? Second row and the third row, is it? And for the second dimension, you're going to do what? You're going to include everyone, is it? So that's how this result gave us, is it? Okay, similar, is it? The second dimension, you pick, you use what? You use the Boolean array, but with first dimension, you do slicing, okay? But we need to be very careful, okay? If you do indexing, okay, it's a little bit of different story here, okay? So here it says, okay, indexing. Basically, whenever you have the comma, this means first dimension, second dimension, is it? So you want to pick out item. So then in that case, both should have the same dimension numbers, is it? So that's why over here, B1, you have two truths, is it? And then B2, you also have two true. If you have three true, that's going to cause a problem, okay? So both in this case, when you do the indexing, so that's why we say it's a weird thing to do, okay? So when you do indexing with Boolean array, is it? Then the both dimension should be the same. Be same, okay? So like over here, both are two. Is it both are two dimension, okay? So be very careful here. Okay, what is the next one? And this one is very, I personally think it's quite powerful, okay? It's Numpy IX under method, okay? And what it plug in is, if you recall, we learned is a single asterisk arguments, etc. Okay, so let's take a look. This is a Numpy array. So we have this Numpy array. So it's 0, 1, 2, 1, 2, 3, 4. So it's 8 by 4 array. It's an 8 by 4 array. And then if you take a look, close look here. So basically what here you try to do is, you try to do something like this. Previously we learned that you try to pick out certain range of items. Is it? So it's kind of some block, is it, from the original, but you are going to rearrange. Is it? That's why over here, did you see? Here you pick the row, is it? Okay, the first or the second row, the sixth row, this row, and the last row, is it? And the lastly, you pick what? You pick the third row, is it? So third row, that's what that looks like, is it? And then what you're going to do, you're also going to rearrange the column, is it? You rearrange, so you're going to get the last column to what? As the second column, so you're going to do that kind of rearrange. Okay, so with arrays, indexing and slicing, you can do that. There is another way we can do, because this is quite powerful with mesh, okay, mesh processing. Okay, so let's see. Then how do you achieve the same goal? Then you can call this IX underscore, this method, is it? And what? You plug in with the sequences, is it? So this is so this represents the first dimension. So it's kind of like the integer array as indexing, is it? But it's a different concept here, okay? So here it's not indexing. Here it's use whatever you specify dimension to reorganize a mesh, okay? So, and then this is regarding second dimension. This part is the second dimension. So what really it means is you're going to pick each single items as what? So you're going to pick single item as 1, 0. Okay, so this is one pair. And then you move to the second, is it 1, 3? Then you move to the third, 1, 1. Then move to the fifth, 1, 2. Is it? After you get, so this is the first one, is it? Then you move on to the second one, it's 5. And keep repeating, is it? So 5, 0, then 5, 3, and 5, 1, and 5, 2. Is it? You're going to keep doing like this, is it? And you're going to have like, you get each individual item out, is it? And rearrange as a new array. Okay, so that's why we call it, it's a mesh. Okay, it's a mesh. So you can use this way to build the mesh. Okay, it's quite useful, especially if you want to do a lot of huge matrix processing. Okay. And then over here it shows, it says, okay, if you want to take a look, okay, what that means. So over here, that means this is going to be the first dimension, is it? So kind of give you the column vector. This is second dimension, is it? It's regarding the row vector, okay, row vector. And like previously we explained, so basically this Python method can divide into 2 parts. Is it the first part? Then it says composed with the input, first input array. Is it? And it become column vector. Is it? And the second part then become a row vector. Okay, as what we just saw. Okay, then let's take a look. Take a look more example. Okay. Regarding, let's see, regarding this one, okay. So it's kind of more complicated, okay. So here we have array A, okay. Array A says it's creates with those 4 numbers, is it? And this is array B. It's all 1 dimensional. Array C. So all 3 of them are 1 dimensional. Is it 1 dimension? And then you plug in all these 3 1-dimensional array into this ix underscore method. Is it? And as we previously explained, it's going to build the mesh. Is it? So this time, that's going to give you back what a 3D array. Okay, because there are 3 import sequences. Okay. How do you get the 3 parts? You can get all of the 3 parts out. We call it AX, BX, and CX. And you can clearly see with the first part, that the first part looks like this. Did you see the first part? Be careful, okay, we have 3 brackets because it's 3D array. It's a 3D array, okay? So over here, the first dimension, we get it AX. And then if you take a close look, the second dimension, BX, is it? Second dimension, be careful, okay, about the difference, is it? So second BX, it's 854, is it? 85, but it's kind of, you reshaped it, okay, reshaped it. Now AX compare with, this is 1 dimension, this is 3 dimension. BX, it's the same thing, compare with B, it's changed to 3 dimension. Okay, 3. And then CX, it's the 3rd dimension. It's the 3rd dimension. Even though it looks like that, but over here you just have 1 square bracket. Here you have 3 brackets. Is it? So this is for the 3rd dimension. Okay. So each one of it corresponding to their corresponding dimension. Okay, dimension. And if you take a look, the shape, it clearly tells you that on the 1st dimension, it's the original numbers. Okay, and because of this, then we can do kind of matrix operation, is it? You can let bx times cx and then plus ax, is it? So this is once again, it applies NumPy arrays element wise arithmetic operations, is it? Okay, so first it's going to do what? Going to do bx and cx. Is it bx and cx? Okay, what it does, it's what? It's 8 times, so use the bx, is it? And previously we said it goes from the first one, is it? And then use the first one to go with, hold on, let me. So it's going to apply this single 8 item, is it, from bx and times 1 by 1 to cx corresponding items. Is it? That's you get this part. Is it get this part? So that's why you have 1, 2, 3, 4, 5. Is it for the third dimension? Is it? So that's how we come up with 40. Is it 5 by 8? 4 by 8 is 32. Is it? And 8 by 8 is 64. Is it? And oh no, 6 by 8 is 48. That 8 by 8 is 64. And 3 by 8 is 24. Is it? That's the most innermost items. Is it? Innermost items. And what? Then you are going to add what? Add AX. Is it? What is AX, a corresponding item? It's 2. Is it? So you are going to add 2 to each of the items. So that's why here is a change of 40 and 34 and 50, 66, 26. Is it? If you take a look at the output, that's how you come up with the innermost, the third dimension items, each one of it. Is it? And this corresponding to the second dimension. Is it second dimension? Okay. So basically, you can see using this IX, it's quite flexible. Is it? In this case, you kind of build a 3-dimensional array with 3 one-dimensional array. Is it? Yeah, so that's why we call this, it's quite powerful for mesh, to build a mesh, okay. Okay, this is this IX operation. Hold on, we have one more coming. And what next we try to show is about NumPy array, apply NumPy, using NumPy. Also, it supports file processing. Okay, file processing. So let's take a look. So first, let's get to that data to see. Let me do the copy, Control C. And I'm going to stop sharing to go to that website. Do Control V. Control V. I cannot do that. Hold on, okay, let me copy that data set. Control C. Okay, for some reason, let's get back to sharing. Sharing, I believe it is this. Okay, and I copied that website. So this website, okay, it's the UCI from UCI EDU, ML's machine learning database. So over there, this is a very classic machine learning data repository. Okay, and over there, there is called the Iris data. So it's a very classical one. A lot of research use this to do machine learning. Okay, and what the data looks like. Hold on, let me annotation that clear everything. And then I need to stop sharing again, I believe. I'm not sure. Let's see. Annotation. Let's see. I bring that. Hold on. Okay. Oh no, it went to a. Let's stop sharing. Okay. Let's re-sharing so that you will see what the data looks like. Okay, so over. Can you all see my screen now? Right now it's a black screen. Can you all see it?
Yes, we can see.
Okay, very good. Thank you. So if you take a look, so that's what that Iris data looks like. Okay. So over here, if you take a look at just some data, is it some number? So, and the last one is a string. Is it? So that's what that file looks like. Okay. And then let's go back to our code. Hold on, where is the, I need to get that note back. So anyway, so here the idea is, anyway, that's a plain text file, is it? And we want to read that data, is it? And we also, because over here it's Numpy, is it? Library. So we will see if there is any way we can directly import it as Numpy array, okay? So over here, there is a method in Numpy package called generate, so gen from text, this method, okay? If you call this method and the argument you can plug in, so over here is a file, okay? And our file, we get our file from internet. So this is also supported, okay? You can also have the file stored in local and access it. So it doesn't matter, okay, over here. So anyway, this is a file name. And you are going to specify how do you get each token out. Okay, we call it a delimiter, is it? So over here, we just saw it's some number, is it? So it's 5.1 dot and 3 point dot. It's all separated by, or not dot, by comma, is it? So we specify the delimiter as comma, is it? And the last one is the data type. Okay, and if you take a look here, it says equals to type. What is type? So we define the type here. Is it? The type here is that if you take a look closely, it matches float, float, float. Is it? And F is also float. Okay. And the next one is also float. The last one, this S represents string. Okay, string. And you may say, what's the difference between float and F? Okay, so one is F8 and one is F4. Okay, so F is 4 bytes and this is 8 bytes. Okay, so that's the difference. And the last one is string. So you define, oh, sorry. So anyway, so over here, you define the types when you read the data file. Okay, you want to extract the corresponding data as what type, because otherwise it should be all considered as a string, is it? And then you need to do conversion. Then in this case, you don't need to worry about that. It automatically will convert the data to number, is it? Because NumPy basically mostly deal with numbers, is it? Numbers. Okay, then we want to get the top number of rows, and we want to see its data, is it? Then did you see you can just do the regular slicing, is it? And here it shows us the first 3 rows of the number, is it? And the data type, it also gives you, is it? Okay, the first one is floating number. The second one is a floating number. So this over here means the first variable, second variable, third, fourth, fifth. Okay, the corresponding argument, is it? So anyway, so this shows you can use this method, okay, called generate from text. And then we can also do the other way. There is another method in NumPy. So np dot, it's called load text. Okay, load text. It's pretty similar if you take a close look. Is it the file name, location, is it? And the data type you can specify, delimiter, is it? And here it also says use columns, is it? And after we see, is it? And if you want, you can get the top certain number of items to take a look. And this is the very first one, is it? Very first. And also it just tells us the data type. We use the type method. It says NumPy array, is it? So the load text also gives you a NumPy array, okay? So this is ND array. Okay, so it's quite powerful, is it? So that you don't need to do conversion again, as a conversion again. And this is the first item. And you can also get the shape, is it? So all of those here it shows. And what the next part to try to show is, because it's a NumPy array, you can do loop, as if we do loop. Okay, so here when we do loop, is it? When we do loop, then we also add each row, is it, to a list, is it? So we convert sequence to the list. And over here, you can also delete a certain number, is it? And then we expand the list, as if we keep concatenate to the list. So over here, just try to show, after you get the array, you can do some further processing, as if further processing. And then we can get to the first 3 rows from the list, is it? And you can convert the list back to array, okay? And then you can get to the first 3 items from the array. So what here try to show is, after you read the data from a file using NumPy load text, is it? You can do whatever processing you would like, okay? And next, let's see. Here we have another file, okay, called gog.csv file, okay? So it's a comma separated value file, okay? Anyway, it's a plain text file. And here to try to show, so we need to be careful, okay, when we use the load text and the generate from text, okay? So we are going to apply load text on a new file. Later, I'm going to show you the file, okay? So what this file has, it's some Google's stock data, okay? So what it has is some, so here it also defines the data type, is it? For the data type, it says, okay, what the name? So here you have key value pair, is it? Here you have key value pair, and the formatting, is it? Okay, so regarding the names, it's date, open price, high price, low price, close price, just volume, those info. And here for the formatting, you specify it's NumPy floating or NumPy string or whatever, is it? And here says delimiter, it's still comma because this is CSV file, okay? And then here you have skip row. So what over here, it means I want to skip the first row. Okay, I will start from the second one. Okay, so, and here says unpack is true. Okay, so you can also do unpacking because basically, if you recall from the previous example, the load text will return an array. Is it a ND array? Is it anyway? It's a NumPy array, is it? And over here, because you said unpack is true, is it? Unpack is true, and you see here we have 1, 2, 3, 4, 5, 6, 7. We have 7 individual variables, is it? Then basically over here, each one of it will collect the corresponding column. So that's why we say over here it's unpacking. Okay, so A will get the first column data, B will get the second column. So something like that, is it? And here I did check, is it? For A, I want to output everything. So it's all date, is it? It's all date. If you get B, it will be the open price for everything, is it? Okay, so for this, so anyway, what here try to show for the load text, and if you do unpack, and if you assign it to individual variable, it's working, okay. And but be careful if you use generate from text, we do the similar thing, okay, similar thing. And if you do that unpack, if you want to set it true and do the unpack, do the packing, is it unpacking? That will cause trouble, that won't work. Okay, that won't work. So over here, then you just set the unpacking as false and assign it to some variable A. Okay, variable A. And here you can also see what A has, the shape. Is it? The shape is 8. Is it? And then I can get whatever the first one. Is it? So the first one corresponds. So basically this A include all of this. Okay, so all 7 columns. Okay, and all of the number of rows. So we have 8 rows in this case. Okay, 8 rows because we skip one header. Is it? Okay, and so this time this A is not just regarding date. Is it? So if you want to just get off the date out, compare with the load text, it's a little bit of more complicated. Okay, so you need to get the first rows, that certain item out, and then you kind of expand it with NumPy arrays, V stack, or vertical stack. And then lastly, you can get all of the first column out. So what here try to show is if you use this gen from text, compare with the load text, it's a little bit of more complicated, okay. And then next, let's see. We already showed that example. Yeah, so the last one in this quick start, what we try to show is, because a lot of time nowadays, when you collect data from internet, it's a JSON file, okay, because API from backend to front end normally transfer JSON file, also plain text, okay? And a lot of time for data analysis, if you can convert to CSV file, it may be much more convenient, okay? So here I just show, this is my version, okay? It's not the best option, okay? You can try to get some other best option. But anyway, just to show you some idea, okay? So here we have some JSON file, and we are going to write the JSON file content to a CSV file. So that's why I open the CSV file with written mode, okay, written mode. And then you just start to write the file, okay? And then I open the JSON file, is it as read mode, okay? After that, you can load. You can call JSON file as a load function. Is it what load does is convert JSON string to Python data, okay, to Python data. And then what next we try to do is we get each record out of the JSON file, is it? And because JSON is a key value pair, is it? So you can extract the value from the specified key. Is it from the specified key? Okay. And after that, you can also write the corresponding value back, is it, to the CSV file? Okay. So that's what this example try to show. Okay, so you can clearly see from the JSON file that you can get all of the key and the individual value part. Okay, individual value. And what that file looks like, let me next show you the file looks like. Okay, to go to here. Is it where's the data file? Okay, yeah. Let's data file. Let's get to the data. Open with, and let's share that file. So if you take a look, that's what that CSV file, okay, CSV file looks like. Is it? Okay. Okay, so that's, so I believe that's all for this first quick start note we completed. So on Wednesday, we will start to learn more.